This is section 11.3, and I'm going to introduce polar coordinates. But first, let's start with a review problem. Why don't you pause the video and see if you can do this review problem? You should get, as your answer, y equals 9x minus 1. Okay, hopefully you did that. And so let's go through the steps. First, we need the slope of our tangent line. So let's find the slope in general, and then find the slope when t is 2. So the formula for the slope of a parametric curve is dy dx equals dy dt over dx dt. Now for dy dt, we need the quotient rule. So I want the derivative of the top, which is 1, times t minus 1, minus the bottom, the top times the derivative of the bottom, which is 1, divided by the denominator squared. Now for dx dt, I can just use the chain rule. Think of x as t plus 1 to the negative 1. So bring the negative down, subtract 1 from the exponent, and we're going to get negative 1 over t plus 1 squared. All right, the top simplifies to negative 1 over t minus 1 squared. And now multiply by the reciprocal of the denominator, which gives me t plus 1 squared over t minus 1 squared, which I can write like that. All right, that's the slope at any value of t. But the slope of our tangent line is dy dx at t equal 2. So I put 2 in here, and I get 3 over 1 squared, which is 9. The other ingredient I need for a tangent line is a point on the line. So I need my x naught, y naught, and that's going to be x at 2, y at 2. Which is put 2 in for t, and I get 1/3, comma, 2. Now use point slope. Y minus 2 is 9 times x minus 1/3. Solve for y, and we get y equals 9x minus 1. Okay. Polar coordinate system. Instead of describing a point with two coordinates x and y, we use r and theta. R is going to be the distance from the origin, directed distance, meaning r can be negative, and I'll explain that below. And theta is the angle from the positive polar axis, which is the positive y-axis, to the line subtended by the point. So if I draw a line between the origin and the point, theta is the angle between the positive x-axis and that line. If theta goes this way, that's negative theta. So let's plot some polar coordinates. I like to go to the angle first and then to r. So for 2 comma pi over 3, I'm going to go to angle pi over 3, which is up here, and I go 2 units out. So 1, 2. So this is like homemade polar graphing paper. It's got the common angles that we see, pi over 6, pi over 4, pi over 3, and it's got rings around the origin. The first ring would be 1 unit from the origin, that would be r equal 1. The second ring is 2 units from the origin. Third ring is 3 units from the origin. All right, for the next one, theta is negative pi over 6, so I go down here to negative pi over 6, that's this angle, and I go 3 units out. Oh, I wanted to label this. So this is A, and then 3 units out, that puts B right there. All right, what do you do when r is negative? So for this one, we go to the angle 5 pi over 6, that's this angle here, and if r is negative, you go into the opposite quadrant. So instead of going 3 units in this, from the origin this way, I go 1, 2, 3 units this way. And so C actually sits where B sits. So polar coordinates are not unique. You can have two different labels for the same point. All right, for D, we're going to go to the angle pi over 2, which is positive y-axis. And I go 1, 2 units in this direction. So this is D. E has r equal to 0, and I have a note here in red. When r is 0, you're always at the origin. The angle is irrelevant because if you're 0 units out from the origin, you're at the origin. So this is E. F, I go to the angle 0, that's the positive x-axis, and I go 2 units out. Let me erase this line. So 1, 2, this is F. G, I go to the angle 2 pi over 3, which is up here, and I go 2 units out, so this is G. And finally, for H, I go to the angle pi, that's the negative x-axis, and I go 3 units in the opposite direction. So 1, 2, 3, H is right there. Okay, now you try. So pause the video and plot these points. And I'm going to pause it and plot the answers while you do that. Okay, so there are the answers. You can pause it and take a look at those and make sure your answers agree. Now let's sketch some regions. The first one is r less than 1. Now r is the distance from the point to the origin, and there's no condition on theta here. So if r is strictly equal to 1, then that's a circle 1 unit from the origin. Now we want r less than 1, so I'm going to use a dotted line around that circle, r equal 1, and then I want to shade everything inside. If that had been r less than 1 and, theta between 0 and pi, then I would have only shaded the top of the circle. But since there was no condition on theta, I want just to let theta go from 0 to 2 pi. Okay, next one, theta goes from pi over 6 to 5 pi over 4. So theta equal pi over 6 is about here, and 5 pi over 4 is about there. So we want angles in this region, and we want to be between 1 and 2 units from the origin. So I'm going to fill in the annulus, piece of a bagel here, like that. And this would have solid lines because R is between 1 and 2, including 1 and 2, and then these would be solid because you want to include those two angles. Last one, there's no restrictions on the R. So R can be anything. Theta between 0 and pi over 4, here's the angle pi over 4. So I want all these points, but wait, there's more. R can be negative, so this is R positive. Down here is R negative. So we actually get all of that. All right, pause the video and you guys try graphing these 3 regions. All right, so hopefully you got these. Just one thing I wanted to point out for this last one, you've got a dotted line on the circle of radius 2 and a solid line on the inside on the circle of radius 1. All right, coordinate conversion. So to go between polar and rectangular, you really just need this triangle here. We've got theta, r, x, and y. So we know that, for example, so how am I getting these equations here? Cos theta is adjacent over hypotenuse. So if you solve that for r, you get solve it for x, you get x is r cos theta. And similarly, you can solve for y and get y equals r sine theta. Then to go in the other direction, this is a right triangle, so x squared plus y squared is r squared. That will give you r up to 2 values, plus and minus. Tangent theta is y over x. That will give you infinitely many values of theta, but we're only going to pick the values of theta between 0 and 2 pi. All right, so let's do the easy direction first. The easy direction is going from polar to rectangular. So x is r cos theta, which is 2 cos pi, which is -2, and y is r sine theta, which is 2 sine pi, which is 0. So there are no choices to make here. xy is -2, 0. We really didn't need equations to do that. We could have plotted this point in polar coordinates, go to the angle pi and go 2 units out. So the rectangular coordinates for that point are -2, 0. All right, next one, x is r cos theta, so √3 cos pi over 6, and y is r sine theta, which is √3 sine pi over 6. Okay, cosine pi over 6 is √3 over 2, so this is going to give me 3/2. And for the next one, sine of pi over 6 is 1/2, so this is √3 over 2. So xy is 3/2, √3 over 2. Let me circle these. All right. Going the other direction is a little more difficult because you have some choices to make. So the first thing I'm going to do is find r. I'm going to use r squared is x squared plus y squared. So that gives me r squared is 1 squared plus -1 squared, which is 2. So r is plus or minus √2. That gives me r up to sine. Now we're going to find theta. Tangent theta is y over x, which is -1 over 1. So tangent theta is -1. I need to come up with 2 angles between 0 and 2 pi whose tangent is -1. So you have to know your unit circle in order to do this. That gives me 3 pi over 4 and 7 pi over 4. All right, so now we're going to pair the correct angles of the correct values of r with the correct values of theta. In order to do that, we need to know where the point is. So the point, 1, -1, is in quadrant 4. Okay, so if I choose the positive value of r, then I need to choose the angle of these 2 angles. I need to pick the one that's in quadrant 4. That's 7 pi over 4. If I choose -r, I need the angle that's not in quadrant 4. I need the angle that's in quadrant 2, because when r is negative, it's going to bounce me into the opposite quadrant. So those are the only 2 correct answers. Some students like to list all 4 possibilities. So the other 2 possibilities would be -√2, 7 pi over 6, and +√2, 3 pi over 4, and cross out the ones that don't work. 2 will work, 2 won't. Now, why don't these work? Well, if theta's 7 pi over 6, we're down here in quadrant 4, but then the negative value of r pushes us up here. So both of these are in quadrant 2, which is not where you want to be. I just go through and do it like I did the first time. I don't list all 4 and then cross 2 out, but you're welcome to do that. Okay, for the next one, let's find r. R squared is 0 squared plus 2 squared, so that's 4. So r is plus or minus 2. Now we'll find theta. Theta is, tangent theta is 2 over 0, which is undefined. there are only two angles between 0 and 2 pi with undefined tangent. Those are pi over 2 and 3 pi over 2. So to figure out how to pair these, we need to plot the point. X is 0, y is 2, that's up here. So if I want to pick positive r, I need to pick the angle that's going to put me in the right spot, and that's pi over 2. And if I want negative r, I'm going to have to pick the angle down here, which is 3 pi over 2. And this one you could have done just by plotting this point initially, and just, you could do that in your head. You don't need formulas to figure that out because it's just a quadrant angle. Okay, one more and then I'll let you try some. So if we find r, we get r squared is negative root 3 squared is 3. 3 plus 1 is 4. So r is plus or minus 2. Now for theta, we have tangent theta is y over x, so negative 1 over root 3. So I need two angles between 0 and 2 pi whose tangent is negative 1 over root 3. So that's a negative slope and it's gradual. So that's going to be here 5 pi over 6 and 11 pi over 6 over here. All right, we plot the point. X is negative and y is positive. So we're in quadrant 2. So if I pick the positive value of r, I need to pick the angle that's in that same quadrant, quadrant 2. So that gives me 5 pi over 6. And then if I pick negative 2, I want the angle in the opposite quadrant, which is 11 pi over 6. All right, so you try these three. I'm going to pause it and put up the answers while you're gone, and then you can check your work. Okay, so this is what I came up with. Might want to pause it and make sure you come up with the same thing. And then in the second part of the video, we're going to start to convert between equations. So we'll convert Cartesian equations to polar and vice versa.